Hi everyone, welcome to Concentration of Solutions lesson number 1. As always, we'll start the lesson with our starter questions. You should spend no longer than 5 minutes on these. And in that 5 minutes, everyone should get through questions 1 and 2. Most will get through questions 3 and 4. Some will get through questions 5 and 6. These questions are based around the moles and mass content that we learned in the last few lessons. And just a wee reminder of your formula rules. If the formula is not already given to you, you will have to write it. So if you pause the video here, have a wee shot of the questions, and once you're ready, hit play, and the answers will be coming up next. Here are your answers to the starter questions. Mark them and see how you got on. If you're unsure about any, send me a wee email and I'll be able to talk you through it. On to today's lesson. We're learning about concentrations of solutions. By the end of the lesson, you'll be able to state the relationship between number of moles of solute, concentration and volume of a solution. You'll be able to identify and state the concentration and volume of a solution using correct units. And you'll be able to apply your knowledge to calculate the number of moles of solute in a solution. Now, first of all, just a wee bit of revision on what solutions are. A solution is a mixture formed when a solute dissolves in a solvent. Now, just a wee reminder of the rhyme that you can use to remember this. Solute is what you put, solvent is where it went, the solution is what you're producing. Now let's think of a wee example. When salt is added to water, salt water is produced. So we're going to identify the solute, the solvent and the solution here. So the solute is what you put, in this case it is our salt. Okay, and a reminder that the solute is the dissolved substance. Now we added our salt to water, so in this case our solvent is our water. That's the liquid that the solute dissolved in. And we produced our salt water, so that is our solution. Okay, and that is our mixture of solute and solvent together. So we're now going to think about what concentration of solution actually means. So we need to be able to calculate how much of a solute is actually dissolved within a solution. So for example, if you had a solution of salt water, how much salt is actually in that solution? Now instead of using mass, we consider how many moles of solute are dissolved in 1 litre of the solution. So if we look at an example, if we had 1 litre of solution and it contains 1 mole of solute, then we would say the concentration is 1 mole per litre. So when we think about concentration, the units we're going to use are moles per litre, and we write that as mole L to the -1. The -1 just means per. So if you just pause here and copy this note down into your jotter, and once you're ready, hit play. Now that we've learned what concentration of a solution means, we can now connect together the number of moles of solute, the concentration and the volume of a solution. Now the relationship between these can be found on page 3 of our data booklet and is shown on the screen as N equals CV. Now we can represent this in the triangle that's shown below. Now let's just look at what each of these letters mean. N tells us our number of moles of solute. C is our concentration, and remember the unit we've just learned for that is moles per litre. And V is the volume of our solution. Now it's really important to note here that the volume of your solution must be in litres. Now just a wee reminder that 1 litre is equal to 1,000 millilitres, which is also equal to 1,000 centimetres cubed. So if your volume is given in millilitres or centimetres cubed, you must divide that by 1,000 to convert it into litres before you can carry out any calculations. So again, if you just pause here and copy down the triangle and the labels into your jotter. Now, before we can actually carry out any calculations, we need to first make sure we're happy with identifying the concentration and the volume. Now, often people can get mixed up between the two because both units have litres, or sometimes people can forget to convert their volume into litres. Now, we need to make sure we're definitely confident in identifying the correct values with the correct units. So let's look at an example. The beaker contained 250 millilitres of 0.1 mole per litre sodium hydroxide solution. What is the volume and concentration of the solution? So let's start with volume. Now it tells us that the beaker contained 250 millilitres. You need to recognise that millilitres is a unit of volume. But we do not want it in millilitres, we want to convert this into litres. So to do that, we have to divide this by 1000. So we have a volume of 0.25 litres. Now for concentration, we've just learned that the unit for that is moles per litre. So you want to look for what value has the unit moles per litre. And we can see that our concentration is 0.1 moles per litre. Now the most important thing to remember here is that your volume must be in litres. Now let's try a couple of practice questions. For 1, 2 and 3 it's asking you to state the volume and concentration using correct units of each of these solutions. So if you pause the video here, have a wee go at the questions, the answers will be coming up in a sec. Here are your answers. For question 1, the volume is 1.2 litres, concentration 0.1 moles per litre. For question 2, the volume is 0.3 litres because we've had to divide that by 1000 to convert it. The concentration 0.5 moles per litre. And for number 3, our volume is 0.25 litres. Again, we've converted that by dividing by 1000. The concentration is 2.5 moles per litre. Final wee reminder that your volume must be in litres. I can't stress that enough, okay? So now we can actually move on to doing some calculations. So just a wee reminder of the relationship, okay, N equals CV. Now if you're remembering this using a triangle, just a wee reminder that if you cover up N on your triangle, it tells you that C and V are next to each other, and that tells us that C multiplies V in your equation. So let's go on and look at an example. How many moles are in 500 centimetres cubed of 0.2 moles per litre hydrochloric acid? So the first thing we need to do is identify what we know. Now the three values in our equation are N, C and V. We don't know N because that's what we're calculating. Concentration has a unit of moles per litre, so we look for the value that has that, and it's 0.2. Our volume is 500 centimetres cubed, and just a wee reminder, we need to convert that to litres, so we divide by 1000. Step 2 is to calculate what we want to know. We want to know number of moles, so we use the relationship N equals CV. Now we can just plug in our values. N equals 0.2 times 0.5. So our number of moles is 0.1 moles. If you now pause and copy that into your jotter. Now going on to example number 2. Calculate the number of moles in 300 millilitres of a 2 mole per litre solution. Starting with our step 1, identify what we know. We don't know N, our concentration is 2 moles per litre, our volume is 300 millilitres, and we convert that to litres, which is 0.3. Step 2 is to calculate what we want to know. We use the relationship N equals CV again. N equals 2 times 0.3, so our number of moles is 0.6. And again, if you just pause here and copy this example into your jotter as well. Now on to exercise number 5. Questions 1 and 2 are both asking you to calculate the number of moles of solute. Okay, so this is just using our N equals CV relationship that we've learned today. So if you want to complete exercise 5, you can either type up the answers and send them to me, or write them in your jotter and take a photo of the working, and if you could email that by Friday, that would be fab. If you've got any questions or you're stuck on anything at all, just send me an email and let me know. I'm more than happy to help. Okay, so if we just revisit our learning intentions and success criteria for today's lesson, we were learning about concentration of solutions. We should now all be able to state the relationship between number of moles of solute, concentration and volume. We should be able to identify and state the concentration and volume of a solution using correct units. And we should now be able to apply our knowledge to calculate the number of moles of solute in a solution.